This will be our intro notes on electricity, and we'll start making some circuits, and hopefully this will be an interesting unit. It usually is. We'll have to make some circuits for a few days and then come back and do something more complex with them, but just learn about some basic circuits for these last few days. Don't forget that you have a test on Thursday, so make sure you're studying for that. Okay, so if we look at electricity, electricity is really, if you want to define it, is the flow of electric charge. And really the thing that's flowing are electrons. And our electrons, if you remember, are negatively charged. This is based on the idea of the atom. So if you have a nucleus, if you remember, you should. Nucleus has protons and neutrons. So usually the same amount, depending on the element and whether it's an isotope or not. We're going to say they're the same, and in the middle nucleus it has protons, which are positively charged, and neutrons, which have no charge. So we're not going to label those. There's your protons, and on the outside it has some electrons. Put one there, and they have orbitals that they go in. So if we do that, so this would have 3. And you notice, like the nucleus with the protons, that part of the atom is charged positively, and the outer part with the electrons is charged negatively. So, and really, if we wanted to remove these protons, it's very, very difficult. They work on this kind of stuff, splitting the atom. It's not so easy. But these guys out here, these electrons, which are negatively charged, they're relatively easy to get off. And because of that fact, we can use them to form electricity. And the electrons are really worried about are those in the outer shell, or the valence electrons, because they're the furthest away from the nucleus. They have the least of the intermolecular charge affecting them, so they're a little bit easier to remove than others. And really depending on the substance as well. And you can see down here a couple terms you've probably heard before: conductors and insulators. Conductors are easily removed, and insulators, not so easy. So we'll put that in. And really they're not going to be removed. They're just, the configuration of the atom doesn't allow those outer electrons to be removed. The nucleus just has so strong of a pull on them. Okay, and so examples of conductors would be like metals, copper, iron, silver, gold, but also salt water, water with something in it. If it's just water, it's not conductive. If you just have fresh water, it's not going to be a good conductor. And then also insulators is dry wood. Now if it's wet wood, it has water in it, and it just becomes a better conductor. Air is a really good insulator. I think I said conductor. Dry wood is an insulator, and then air is a good insulator. That's when they build houses. They put insulation in to trap air, to not allow the heat from inside to be transferred. It's the same kind of thing with electricity. You don't want to lose the electricity to something outside this circuit or wherever you're directing it, so you need some kind of insulator around it to make sure it doesn't get lost. And then this whole idea of electricity is really based on the law of charges, and that means likes, like positive plus positive, or negative plus negative, they repel. If you try to put two negatively charged items next to each other, they're going to push away from each other. And if you've ever tried to move a magnet, two magnets, you can make one magnet move across the desktop without ever touching it, as long as you have the same ends touching. So that law of charges says likes repel So we'll just put that. They're the same, they repel each other. And then also, opposites attract. So if you have a positive and a negative, they're going to like each other. They're going to be attracted to each other. And they use this idea to create electricity. And how that kind of works is if you have electrons in a circuit and you have them connected. I'm going to erase this here actually. And you have them connected. Let me erase this and I'll explain. And then maybe I'll draw a picture for you. So if you have like a battery, let's just do that. And you have a positive, and you have a negative. Make it a little bit smaller, just for comparison. Usually you hook the wire up and run something like a bulb or something. Now in this wire are electrons. Okay. And on this side you have all these positives. So these are, if you build up enough positive on this side, it's going to push these. Okay. Electrostatic force, and it pushes these electrons. They really get repelled and caused to go to the other side, and when they do that, they pass through a wire or put through a bulb and make it work, or whatever it is. And that's kind of how electricity, or one way it works. Really, this way is your current, the movement of electrons. So it can be that current, and we can have a battery. There's lots of different things. We can use solar power, whatever it is. And even solar power actually depends upon a battery. Wind power, whatever it is. But you really just have electrons flowing through a wire, and you have a whole bunch of charge on one side, less on the other, and that force, that electrostatic force and the law of charges, causes those electrons to move through the wire, the conductor. But also you have this static electricity. And static electricity is really where you just remove something through friction. I'm going to put that in here. So friction. So if you have this, let's see, get rid of this. Okay, so friction. And let's say you have, I'm going to erase this thing here. Hopefully you got it. You can always pause it and come back. So if I have like a balloon, let's see if I can, kind of looks like a fish. That's fine. And then you rub it on somebody's head. It's a pretty big balloon actually. I guess not that big. And then you have a bunch of hair, right? Okay. And there's friction between the hair and the balloon. But the balloon is also an insulator, so it's not going to allow charge to pass through it. But charge can then accumulate on it. So negative, 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 negative. So it gets all this negative charge on the outside of it. And then if you take this balloon away, we go over here, you then have this balloon with a bunch of charges on it on one side. And you hold it next to this person. And because you've moved their electrons, they kind of have now a positive charge somewhat on their hair. And you can actually make their hair stand on end. So it kind of gets attracted to the balloon. You should try this sometime. You can also charge up a balloon, make it stick to the wall, or whatever. That's static electricity, just an accumulation. You rub something through friction, the electrons get placed on something. It usually should be something that's an insulator, so it can hold the electrons and they don't travel somewhere else. And then you can use this charged object to do things, like attract hair or whatever it is. Usually you're going to use it for something more important than that, but this is a good example of how this all works. And as I said before, current is just a movement through electrostatic force. Hook up a battery that's oppositely charged. It pushes those electrons in the wire. That's why you make it through copper, because they're easily removed. They get transferred, and it pushes those electrons through something like a light and then back to the other side of the battery. And if you don't keep recharging that battery, then it runs down, and that's why, because all the electrons get removed, or the positive charge gets removed, and then it has no electrostatic force. So that's our notes on electricity. Make sure you annotate your notes and turn them in for credit, and I'll see you in a couple days.